So introduction, we will be covering trigonometric ratios of acute angle of a right angle triangle, proof of their existence, value of trigonometric ratios of 30 degrees, 40 degree and 60 degree, the proofs and relationship between trigonometric ratios. Then comes the trigonometric identities. In this part, we will be learning very simple identities, not the complex one, very simple identities. And don't worry about the terms, as we will go through the chapter, I will be explaining each and every term to you. So let's start. Let's start from the very basic. What is trigonometry? How do you define it? Like in geometry, you study various shapes, triangles, circles, parallelogram, trapezium. So what you will be studying in trigonometry? So let's start with the very basic. Trigonometry, the word trigonometry itself comprises of trigono plus metron. The meaning of trigono is triangle and metro is measure. The trigono and metro, these are Greek words. These are Greek words. So it's basically a study of measurement of triangles. But measurement in what sense? What will you measure in a triangle? Triangles you all are aware of. You have studied the triangles earlier also. So a triangle is having three sides, and how to measure the angles, three angles of a triangle, that you are already aware. So basically in trigonometry we will be studying the relationship between angles and sides of a triangle. What we will be studying, that let us see. So suppose there is a triangle ABC which is right angled at B, meaning angle B is 90 degree. Suppose angle C is theta. Then let us call side AB as P, BC as B and AC as H. I will be explaining you to the reason why I have mentioned it as P, B and H. For the time being, you just think AB is P, BC is B, AC is H. So what trigonometry will help us? Suppose you are given P. Suppose P is 3. Theta is some angle, suppose 60 degree. Then if you are aware of trigonometric concepts, you will be able to find the other sides. What is H? What is B? So that is the application of trigonometry. When some sides and angles are given, you will be able to find other sides and angles of a triangle. That is the basic application of trigonometry, what you have to study in class 10th. One more thing, friends. Here I have mentioned only right angle triangle, but it is not so. Trigonometric ratios can be determined even for the one more thing, friends. In your syllabus, it is mentioned that we have to find trigonometric ratios for acute angle of the right angle triangle. But that doesn't mean that there are not trigonometric ratios for other angles or for a triangle which is not right angle. But that is beyond the scope of your syllabus, so we will not be discussing it. So now we will be discussing about the trigonometric ratios. So there are 6 trigonometric ratios. First is sine, second is cosine, third is tangent, Fourth is cotangent. Fifth is secant. Sixth is cosecant. In short, they are also known as sine, cos, tan, cot, sec, cosec. So all these six are nothing but the ratios, trigonometric ratios. So once we determine the value of these trigonometric ratios, we will be able to find the relationship between the sides and angles of a triangle. If some sides and angles are given, we will be able to determine the other sides and angles. So let us see what is the value of each trigonometric ratio. In this triangle, I told you that there is a specific reason for which I have named side AB as P, side BC as B, and side AC as H. So you all would be aware of the Pythagoras Theorem, where the sum of the squares of base and perpendicular of a right angle triangle is equal to hypotenuse. So in this triangle, AB and BC are the sides containing the right angle. So as per the Pythagoras theorem, square of AB plus square of BC should be equal to the square of AC. This is Pythagoras theorem. I have named AB as P because we have considered it as perpendicular. I have named BC as B as because we have considered it as base. And AC will naturally be H. There is no need to consider, it will nothing but hypotenuse only. So the value of sine theta, our first trigonometric ratio, is P by H, that is perpendicular by hypotenuse, that means AB by AC. The value of our second trigonometric ratio, cos theta, is B by H, that is base by hypotenuse. What is base? BC. Hypotenuse? AC. Similarly, the value of tangent, tan theta, our third trigonometric ratio, is P by B, that is perpendicular by base. Perpendicular is AB, base is BC. Our fourth trigonometric ratio, cot theta. The value of cot theta is D by P, that is base by perpendicular. What is the base? BC. What is perpendicular? AB. Our fifth trigonometric ratio is sec theta. The value of sec theta will be hypotenuse by base. Hypotenuse is AC, base is BC. The value of sixth trigonometric ratio, that is cosec theta. Cosec theta is H by P. Hypotenuse by perpendicular. Hypotenuse is AC. Perpendicular is AB. So these six are the value of trigonometric ratios. Remember one thing, students, if you study these six values and you just try to remember these six, the rest of the trigonometric chapter will be a cakewalk for you. You will not have any single problem in any of the questions, any of the concepts. Entire trigonometry is based upon these six trigonometric ratios. The rest, all other things that we are going to study in this chapter, we can derive from these six trigonometric ratio. So get this six trigonometric ratio by heart. Wherever you feel the need to note down, you can pause the video and note it down. And after you have noted it down, you can play it again. Now, as we have learned the value of 6 trigonometric ratios, we will try to derive the relationship between them. This will be very useful, because once you learn the relationship between trigonometric ratios, you need not even remember all 6. If you remember 3, that is sine, cos and tan, then you can derive the value of the other 3. So let us see. If you examine carefully, the value of sine theta is AB by AC, and the value of cosec theta is AC by AB. So first relation, if you try to see, suppose we multiply first ratio with sixth, that is sine theta into first ratio is here, sixth ratio is here. We are multiplying both, sine theta into cosec theta equals to AB by AC here into AC by AB. So AC and AC, these two gets cancelled, AB and AB, these two gets cancelled, equals to 1. Therefore, we have just now derived our first relationship between trigonometric ratios, that is sine theta into cosec theta equals to 1, or otherwise you can write it as sine theta equals to 1 by cosec theta. So this is our first relation. Now our second relation, you just multiply the second ratio, that is cos theta, with fifth ratio, that is sec theta. Second ratio into fifth ratio equals to cos theta into sec theta, equal cos theta was BC by AC, sec theta was AC by BC, it's here, sec theta, AC by BC. So AC and AC gets cancelled, BC and BC gets cancelled, equals to 1. Therefore, we have just now derived our second relationship between trigonometric ratio, that is cos theta into sec theta equals to 1, or in other words, cos theta equals to 1 by sec theta. Now we will be seeing our third trigonometric identity. Third identity, for that you multiply third ratio with fourth ratio, that is this and this. So third ratio into fourth ratio, that is tan theta into cot theta. What is tan theta? AB by BC. We can take it from third equation. AB by BC. What is cot theta? We can take it from fourth equation, BC by AB. AB and BC got cancelled, so what is left? 1. Therefore, we have just now derived our third trigonometric relationship between the ratios. Tan theta into cot theta equals to 1, or in other words, tan theta equals to 1 by cot theta. Now we will be seeing our fourth trigonometric relation between the ratios. If you want, you can note it down. fourth relation. For fourth relation, what we have to do, we will divide first ratio by second ratio. So first ratio was what? Sine theta. Second ratio was cos theta. Sine theta is AB by AC divided by cos theta. Cos theta is BC by AC. So AB by AC divided by BC by AC will give us AB by BC. And AB by BC, as we can see from our third trigonometric ratio, is tan theta equals to tan theta. This we got from equation 3 above. From here we can see that AB by BC is tan theta. Therefore, we have just now reached at our fourth relation between trigonometric ratios, that is sine theta divided by cos theta equals to tan theta. Similarly, if you divide second by 1, that is second ratio by first ratio, that means cos theta by sine theta, you will get cot theta. This you try to do it by yourself. You can easily get it. You substitute the value of cos theta from here. Cos theta will be BC by AC divided by sine theta. Sine theta is AB by AC. So you will get cot theta. So from now onwards, I will not be teaching you anything new in trigonometry. Mind it, nothing new. Everything will be the application of whatever we have learned till now. So let us now move on to the first concept, which we can derive by applying what we have learned till now, is the trigonometric ratio of complementary angles. I am writing in short T ratios, that is trigonometric ratios. Trigonometric ratios of complementary angles. What are complementary angles? Two angles are said to be complementary if their sum is 90 degree. Suppose there are two angles, angle A and angle B. If their sum is 90, implies angle A and angle B are complementary. So we have to find the trigonometric ratio of complementary angles. And why is it actually required? Suppose you know the value of sine theta. Somebody asks you sine theta is some value, suppose sine theta is x. Somebody asks you to find the value of sine 90 minus theta. 90 minus theta, what will be the value of sine 90 minus theta? So if you are aware of the trigonometric ratios of complementary angles, you can easily find this thing. You need not know the value of 90 minus theta. You can easily find it in reference to the theta. That's why it is required, and it will help you in solving the problems that you will be getting in your examinations. First of all, we will draw a triangle. A right angle triangle in which angle B is 90 degree. Suppose C is theta. Angle ACB is theta. Now you are aware that the sum of all the angles of a triangle is 180 degree. Therefore, angle ACB plus angle ABC plus have already assumed to be theta. Angle ABC will be 90 degree because it is a right angle at B, plus angle BAC equals to 180 degree. This means angle BAC is equals to 180 minus 90 minus theta. That is 90 minus theta. So angle BAC will be 90 minus theta. Angle BAC is 90 minus theta. Now what we will be doing, we will be writing all the trigonometric identities with respect to theta and with respect to 90 minus theta. So first let us write through theta. T ratios, that is trigonometric ratios in respect of angle theta. So what I just now told you, that you always mark the side which is opposite to the angle in respect of which you have to find the trigonometric ratio as perpendicular. So when we are finding trigonometric ratio in respect of theta, we will mark the side which is opposite to it, that is side AB, as perpendicular. The other side containing the right angle, that is BC, will be marked as base, and the third one will become hypotenuse. Now it will be very easy for you to write trigonometric ratio. First ratio is sine theta, that is P by H, perpendicular by hypotenuse. Perpendicular by hypotenuse, that is AB by AC. Second, cos theta, base by hypotenuse, that is B by H. B by H will become BC by AC. Third is tan theta, that is perpendicular by base, that is AB by BC. Fourth is cot theta. Cot theta is base by perpendicular, but now we have learned the trigonometric ratios relation. So cot theta is also 1 by tan theta. So 1 by tan theta is base by perpendicular, that is BC by AB. Fifth, sec theta. Sec theta is hypotenuse by base. But just now we have learned the relationship between trigonometric ratios, in which we learned that sec theta is 1 by cos theta. That's why 1 by cos theta will be h by b. So sec theta is h by b. Hypotenuse is AC, base is BC. And the last trigonometric ratio, cosec theta. This is hypotenuse by perpendicular. And cosec theta is also 1 by sine theta. So 1 by sine theta is h by p. H is AC, P is AB. So we have written all the 6 trigonometric ratios in respect of angle theta. Now what we will do, we will write all the 6 trigonometric ratio in respect of angle 90 minus theta. Now while writing, now we will be writing trigonometric ratios in relation to angle 90 minus theta, that is angle B, A and C. Only thing we have to keep in mind is we have to change the nomenclature of perpendicular, base and height. While we were writing trigonometric ratio in relation to the angle ACB, that is angle theta, we mark the side which is opposite to theta as perpendicular, the other side which consisted of 90 degree as base, and the third side as hypotenuse. So now we are writing trigonometric ratio in relation to angle 90 minus theta. So side BC will become perpendicular, side AB will become base, and hypotenuse will remain as it is. Now sine theta will always be p by h. So sine this angle, sine 90 minus theta is p by h. Here p is BC, h is AC. Cos 90 minus theta is b by h. B is AB. AB by h. AC. Tan 90 minus theta is perpendicular by base. Perpendicular is BC. Base is AB. Cot 90 minus theta is 1 by tan theta. That is base by perpendicular. Base is AB. Perpendicular is BC. Sec 90 minus theta is hypotenuse by base. Hypotenuse is AC. Base is AB. Cosec 90 minus theta is hypotenuse by perpendicular. Hypotenuse is H. That is AC. Perpendicular is BC. Now what we will do, we will compare these two sides, this side and this result. If you do that, you will see that sine 90 minus theta, that is BC by AC, is equal to cos theta. So we have just now see the relationship of the complementary angles. So I will be erasing this part. Here we will be writing the relationships. If you have not noted down, you can always go back to the video, pause it and note it down. In the examination, you will not be getting all these theory parts. Maybe a few questions, but that will be very less. But all these are very, very important while solving the problem. If you don't understand theory, solving the problem will be very, very difficult. And mind one thing, that you never try to mug up mathematics. You cannot. A very few things you have to mug up. Rest everything you have to learn it. You have to understand. You have to apply your mind. Only then you will be able to solve mathematics and enjoy it. Otherwise, it will become a very big headache for all of you. So now we have written the trigonometric ratio in relation to the theta and its complementary angle, that is 90 minus theta. And by comparing the two sides, we will be getting the results. So first we will compare sine 90 minus theta. Sine 90 minus theta is BC by AC. And cos theta is BC by AC. So first relation that comes is sine 90 minus theta is cos theta. Now you compare cos 90 minus theta, that is AB by AC. If you see this side, sin theta is AB by AC. So we get our second relation. Cos 90 minus theta is sin theta. Now we will be comparing the third relation. Tan 90 minus theta, that is BC by AB. Now you see this side, BC by AB is here, that is cot theta. So we got our third relation. Now we will be looking after fourth relation between complementary angles. Cot 90 minus theta. Cot 90 minus theta is AB by BC. Now you see this side. Where is AB by BC? See, there, here you find AB by BC. That is tan theta. Now we will be seeing the fifth relation, that is sec 90 minus theta. Sec 90 minus theta, that is AC by AB. Now you come this side, you find where is AC by AB. You see, here is AC by AB, that is cosec theta. So sec 90 minus theta is cosec theta. Now we will be finding our sixth and final relation, that is cosec 90 minus theta. Cosec 90 minus theta, that is AC by BC. Now you see this side, where is AC by BC? Here you find AC by BC, that is sec theta. So cosec 90 minus theta is sec theta. So we have derived our 6 relations between complementary angles and their trigonometric ratio. So sine 90 minus theta is cos theta, cos 90 minus theta is sine theta, tan 90 minus theta is cot theta, cot 90 minus theta is equals to tan theta. Similarly, sec 90 minus theta is cosec theta, cosec 90 minus theta is sec theta. Now, right now it will be looking a little bit difficult to you, although we can derive it, but every time you cannot do all these calculations and see what is the value of sine 90 minus theta, what is the value of tan 90 minus theta in terms of theta. But don't worry, once we will be doing the problems, if you do 10 to 20 problems, it will automatically get etched in your memory and it will become it will come naturally to you. Whenever somebody asks what is sine 90 minus theta, you will immediately say cos theta. So now we will be going to the next topic. Now we will be finding the values of some specific angles, the trigonometric ratios of some specific angles. Till now what we were finding was a very generic, that in a triangle, if this angle is theta, then value of sine theta will be AB by AC. Similarly, other trigonometric ratios. Now what we will be finding is what will be the value of sine theta if theta equals to, suppose 30 degree, 45 degree, 60 degrees, like that. So we will be finding the specific values. In your syllabus you have 0 degree, 30 degrees, 45 degrees, 60 degree and 90 degree. You don't have to find the specific value of some other angles, trigonometric ratio of some other angles, say sine 15 degree, sine 25 degree. You don't have to find it in your syllabus. That's the beyond the scope of your syllabus. So let's start with 0 degree. We will be starting with finding the value of 0 degree. Trigonometric ratios of 0 degree. So suppose a triangle ABC in which angle ACB is theta. Then this will be P, B. Always whenever you do the problem, you mark PBH with pencil if you want to delete it later. Otherwise, even if you leave it as PB and H, your marks will not be deducted. In fact, that will be considered as good as you have the clarity of concept, which side to take as P, which side to take as B, which side to take as H. So whenever you are doing a trigonometry problem and you have if you have confusion regarding how to write the trigonometric ratio, always mark P, B and H. And how to mark P? The angle in which relation you are trying to find the trigonometric ratio, the side opposite to that will always be perpendicular, that is P. The other side containing the right angle will be B, and the third side will naturally be H hypotenuse. So the value of sine theta will be perpendicular by hypotenuse, that is AB by AC. Now what we have to find the value of sine theta when theta equals to 0 degree. Theta equals to 0 degree means the angle BCA, that angle becomes 0 degree. That angle becoming 0 degree, when will it, suppose here is angle, we will understand it through practical example. Suppose this is angle, some angle X. If you reduce this angle a bit, then it will become like this. to become y. If you reduce it even further, it becomes z. Like that, if you keep on reducing the same way, a time will come when the line AC will coincide the line BC. A time will come when line AC will coincide the line BC. Here angle was x, here y, here z. The angles are decreasing. Suppose, just for the purpose of example, I am telling that suppose here it was 70 degree, then here it would have become 60 degree. Here it has become 30 degree. Here it has become 15 degree. Now, take one more example. Here it might have become 10 degrees. Similarly, a stage will come where if you decrease the angle to such an extent that line AC and BC coincides, that is, there is no angle between them, the line AC and BC has coincided, and that's the point when we say that this angle is 0 degree. It becomes simply like this, single line. Now here we saw what was the value of sine theta. Sine theta was AB and AC, but when AC and BC it has coincided, then the length of this line AB, it will become 0. So sine theta, that is AB by AC, from here I am taking, AB has become 0, AC will remain some length, whatever it is. So 0 by AC will be 0. So we have just now derived the value of sine 0, that is 0. If you have understood the concept which I have applied in deriving the value of sine 0, there will be no difficulty in understanding it. I will explain it again. For the purpose of illustration, we have drawn one big triangle in which we have assumed this angle is 70 degree. Then in the next triangle, we have reduced that angle to 60 degree. Similarly, if we keep reducing this angle, then this difference will reduce. So a time will come when you reduce the angle sufficiently so that this line segment, this line AC coincides with BC and the angle between them gets nullified, that is, it becomes 0. In that condition, the point A has coincided with point B. Not actually coincided, it will not coincide, but the point A, point B and point C, it will become concurrent, it will come in same line and the angle will become 0, the length of AB will become 0. So AB has become 0. If you substitute the value of AB as 0 in this equation, that is sine of 0 degree equals to 0 by AC, sine of 0 degree is 0 by AC equals to 0. So we have derived the value of sine 0. Now we will be deriving the value of cos 0. So cos theta is base by hypotenuse. Base is BC. Hypotenuse is AC. Now when you have reduced theta to 0, that is, this angle has been slowly reduced, then the point A comes to the point B, that is, BC and AC becomes equal. So cos 0 becomes, cos 0 degree becomes 1. So we have derived the value of sine 0 and cos 0. Now we will do one thing. If we have derived the value of sine 0, then we can easily derive the value of cosec 0. Cosec theta was 1 by sine theta. So we will do that. Let me erase it. We have derived sine 0 degree equals to 0, cos 0 degree equals to 1. While learning the relationship between trigonometric ratios, we have learned that cosec theta equals to 1 by sine theta. Therefore, cosec 0 degree will be 1 by sine 0 degree. That is 1 by 0. And if any, you will be knowing that if any number is divided by 0, the result is undefined. So, cosec 0 is undefined. Similarly, now we will be taking the value of sec 0. While learning the trigonometric relationship between trigonometric ratios, we have learned that sec theta is 1 by cos theta. Therefore, sec 0 will be 1 by cos 0 degree, that is 1 by 1 equals to 1. Therefore, the value of sec 0 degree equals to 1. So what I had told you earlier, that the concepts which we learned till the point we learned the value of complementary angles, the relationship between complementary angles, that was our real learning of trigonometry. Whatever we are doing now is only the application of whatever the concepts we have learned earlier. So this part will be very easy. See how we derived the value of sine 0 and cos 0, and now we are applying it to find the value of sec 0, cosec 0. Now we will apply the same to find the value of tan 0, cot 0. So now we will find the value of tan 0. Tan theta, as per the relationship between trigonometric ratio, we learned that is sine theta by cos theta. Sine theta, therefore tan 0 will be sine 0 degree by cos 0 degree. Sine 0 degree is 0, cos 0 degree is 1. So tan 0 degree will be 0. Similarly, the value of cot 0 degree. Now cot theta, as per the relationship between trigonometric ratios, is cos theta by sine theta. Cos theta is 1, sine theta is 0. So it becomes undefined. So we learned that the value of sine 0 is 0, cos 0 is 1, tan 0 is 0, cot 0 degree is undefined, sec 0 degree is 1, cosec 0 degree is undefined. Now we will be moving forward to the next angle. But before covering the angle 30, 45, 60, I will be covering the angle 90 degree. Now we will see the value of trigonometric ratios of the angle 90 degree. So while we were trying to find the value of angle 0 degree, we were decreasing the value of angle theta from 60, 40, 30, like that we made it 0, and we saw what happened. Here we will be doing the opposite. We will be increasing the value of angles. So here I have drawn three triangles. First triangle, angle of value of the angle theta I have taken 40 degrees. Suppose, it's just an assumption, suppose it is 40 degree. In the next figure I have increased it to 70 degree. Third figure I have increased it to 85 degrees. Similarly, if you go on increasing the angle of a triangle, a time will come. See what is happening. Here this length BC, suppose 5 centimeter. Here this length BC has reduced, might have become 4 centimeter. Just I am assuming. Here it might have become 3 centimeter. So as the angle is increasing, this length is decreasing. So when you make it 90 degree, a time will come when this B and C will coincide and the length of BC will become 0 and AC will become AB. So if you have understood this much, what we have to do next is simply apply the value of trigonometric ratios and we will get the value of trigonometric ratio for 90 degree. So let's start with sine 90 degree. Sine 90 degree will be AB by AC. From here we can see AB is equals to AC. So AB by AC will become 1. Similarly, cos 90 degree will be BC by AC. BC from here we can see is 0 AC. So it will be 0. Now once you have derived these two, can you derive all the others very easily? How? Tan 90. What will be the value of tan 90? Sine 90 degree by cos 90 degree equals to 1 by 0. That is undefined. Why? Because if you divide a number by 0, the result is undefined. Cot 90 degree. What will be the value of cot 90 degree? Sec 90 degree, cosec 90 degree. All of that you can derive yourself. I am leaving that to you. You can derive it yourself by applying the relation between trigonometric identities. Now we will be deriving the value of trigonometric ratios for 30 degree and 60 degree. This question has already been asked in the board examination earlier. That derive the value of, they will give you some specific trigonometric ratio. Suppose derive the value of sine 60 degree or cos 30 degree, like that. So for this, first of all, we will have to make a equilateral triangle. So we have made that equilateral triangle as ABC. And what is an equilateral triangle? In which all the sides are equal and all the angles are equal to 30 degrees. So in this equilateral triangle, AB equals to BC equals to CA, and all the three angles are 60 degree. Now what I have done, I have constructed one perpendicular from point A on the line BC or the side BC of the triangle. And as you are aware that perpendicular from A to side BC in an equilateral triangle will bisect the line BC. Bisect means it will divide it into two equal parts. So the point D is dividing the line BC into equal parts. Therefore, BD is equals to BC. Further, this line segment also divides the angle BAC into equal parts. So, angle BAD and angle CAD equals to 30 degree. What I will suggest you that while I am explaining the concept, you once draw the diagram, you pause the video, you draw the diagram in your notebook. After that, you will be able to better understand the concepts because the figure will be in front of you. So angle BAD equals to angle CAD, that is 30 degree. Now if we assume all the three sides of equilateral triangle to be A, then BD will be half of BC because the point D has divided the line BC into two equal parts. So if entire line segment BC is A, so we have assumed that AB equals to BC equals to CA equals to A. Therefore, BD equals to DC. This BD equals to DC. It is half of line segment BC by 2. Therefore, A by 2. So, this will be A by 2. This will also be A by 2. So, please note it down. I will delete it. See, in the beginning itself I told you, if we know the value of sides and angles, we can very easily derive the trigonometric ratio. So here we know the value of sides, we know the value of angles. So let us consider, now this equilateral triangle is divided in two right angle triangles. Let us consider any right angle triangle. We will consider triangle ABD. Triangle ABD. In this angle BDA is 90 degree. AB is A, BD is A by 2. Now by Pythagoras theorem, AD square equals to, AD square plus BD square equals to AB square. That is AD square plus BD square. BD is A by 2, so BD square, A by 2 square equals to AB square, that is A square. Implies AD square plus A square by 4 equals to A square. So AD square equals to A square minus A square by 4, 3A square by 4. Therefore AD will be under root of 3A square by 4. So from here A by 2 will come out, A by 2 root 3. Therefore the value of AB will be A by 2 root 3. So now in a triangle we know the value of all three sides, we know the value of angles, we can very easily derive the trigonometric ratio. So if you see in triangle ABD, sine of 60 degree. Sine of 60 degree, I am taking this angle 60 degree. Sine of 60 degree will be perpendicular. What is the perpendicular? The side which is opposite to the angle in respect of which we are trying to derive trigonometric ratio. So what is the side opposite to 60 degree angle in triangle ABD? It is AD. So AD by hypotenuse, that is AB. AD is A by 2 root 3, hypotenuse AB is A. So here we can cancel A out, therefore sine 60 degree comes out to be 3 by 2. That is our value for sine 60 degree. Similarly, cos 60 degree will be base, that is BD, by hypotenuse, that is AB. BD is A by 2 divided by A. Here we will cancel A out, so it becomes half. Therefore, cos 60 degree is half, 1 by 2. Okay, I think you will be able to find the value of tan 60 degree, cot 60 degree, sec 60 degree, cosec 60 degree, all of them, by using the relationship between trigonometric ratios. We can also find through the generic method, that is tan 60 degree. Tan 60 is perpendicular by base. Perpendicular is AD, base is BD, AD is root 3 by 2 a, BD is a by 2. So it will become root 3. So tan 60 is root 3. In the other way, if you try to derive it, tan 60 will be sine 60 by cos 60. Sine 60 is root 3 by 2. Cos 60 is half. So root 3 by 2 by 1 by 2. That will also come to be root 3. Similarly, you can derive cot 60, sec 60 and cosec 60. This is very easy. I will leave it to you to derive cot 60, sec 60 and cosec 60. Cot 60 is cos by sine, cos 60 by sine 60. Cos 60 is half divided by root 3 by 2. So it will become 1 by root 3. Similarly, sec and cosec 60 degree, their value you can very easily derive. Now we will be deriving the value of 30 degree. In the same triangle ABD, if we try to derive the value of trigonometric ratios in respect of angle 30 degree, only thing that we will have to do is change the nomenclature of perpendicular, base and height. So once you are deriving the ratio in respect of angle 60 degree, AD was perpendicular because it was opposite to the angle. Now you are deriving the value in respect of 30 degree. So the perpendicular will be BD. BD will be perpendicular. So first value sine 30 is BD, that is perpendicular by AB. BD is A by 2 divided by A, that is half, 1 by 2. Similarly, cos 30 degree, that is base by hypotenuse. Base here is AD, AD by AB. Root 3 A root 3 by 2 divided by A, that is root 3 by 2. Now all the others you can derive by yourself. What is the value of tan 30? Tan 30 will be sine 30 by cos 30. 4. Cot 30. Cot 30 will be cos 30 by sine 30. 5. Sec 30. Sec 30. So sec 30 will be 1 by cos 30. Similarly, the value of cosec 30. Cosec 30 will be 1 by sine 30. It is very easy because sine 30 and cos 30 value is already derived. So you can easily substitute the value of sine 30 degree and cos 30 degree in the further equations, and you can derive the value of tan 30, cot 30, sec 30 and cosec 30 degrees. So we have seen the trigonometric values of 0 degree, 30 degree, 60 degree and 90 degree. Now only thing left is finding the value of 45 degrees. Don't leave these equations like this. You put the value, substitute it and find the value of tan 30, cot 30, sec 30, cosec 30. In the end we will prepare a chart where we will summarize the value of all the angles for all the trigonometric ratios. Now we will be finding the value of trigonometric ratios for the angle 45 degrees. For this, let us assume a right angled isosceles triangle. Isosceles triangle means two sides are equal. So suppose there is a right angled triangle ABC in which AB is equals to BC. AB is equals to BC. Therefore, right angled triangle ABC, angle B is 90 degree. So angle A and angle C will be 45 degrees. Now since AB is equals to BC is equals to A, and since the triangle ABC is right angled, therefore by Pythagoras theorem AB square plus BC square equals to AC square. AB is A square plus BC is A square equals to AC square. AC square equals to A square plus A square, that is 2A square. Therefore AC will be A root 2. That I have already mentioned. Now we know the angles, we know all the three sides. Now it is very easy for us to determine the value of trigonometric ratio for 45 degrees. So we will take sine 45 degrees in respect of this angle. Sine 45 degrees will be perpendicular by hypotenuse. Perpendicular will be the side which is immediately opposite to the angle which we are considering to find the trigonometric ratio. So we are considering this angle, therefore perpendicular will be AB. AB by hypotenuse, that is AC. AB is A, hypotenuse is A root 2. Therefore it is 1 by. Similarly, cos 45 is base by hypotenuse. Here base is BC, hypotenuse is AC. BC is A, hypotenuse is A root 2. So 1 by root 2. Tan 45. Now tan, cot, sec, cosec, I need not derive because you have learned what is the relationship between trigonometric ratio. So tan 45 will be sine 45 by cos 45. Now sine 45 and cos 45 both are same, that is 1 by root 2. So the division will come out to be 1. Cot 45. This is cos 45 by sine 45. Now both are same, so their division will come out to be 1. For sec 45 is 1 by cos 45. Cos 45 is 1 by root 2. So sec 45 will be root 2. Similarly, cosec 45 is 1 by sine 45 equals to 1 by sine 45 is 1 by root 2. So cosec 45 is root 2. So after learning the relationship between trigonometric ratios and complementary angles, we didn't face any difficulty in deriving the value of trigonometric ratio for the specific angles, that is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So now we know the value of all the 6 trigonometric ratios for all the 5 angles, that is 0, 30, 45, 60 and 90. Now we will summarize the value in a table, and as and when we practice the sums where the values will be used slowly over a period of time, the value of each trigonometric ratio you will get by heart. Now through this table we will be summarizing the value of all the trigonometric ratio for the following 5 angles, that is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So we will start with sine. Sine 0 is 0. Sine 30 is 1 by 2. Sine 45 is 1 by root 2. Sine 60 is root 3 by 2. And sine 90 is 1. Similarly for cos 0 is 1. Cos 30 is root 3 by 2. Cos 45 is 1 by root 2. Cos 60 is 1 by 2. Cos 90 is 0. The same way, tan 0 is 0, tan 30 1 by root 3, tan 45 it is 1, tan 60 is root 3, tan 90 is undefined. Similarly, cot 0 is undefined. Cot 30 is root 3. Cot 45 is 1. Cot 60 is 1 by root 3. And cot 90 is 0. Sec 0 is 1. Sec 30 is 2 by root 3. Sec 45 is root 2. Sec 60 is 2. Sec 90 is undefined. Similarly, cosec 0 is undefined. Cosec 30 is 2. Cosec 45 is root 2. Cosec 60 is 2 by root 3. And cosec 90 is 1. So this is a table. You just see it once, and it will be better if you note it down in a piece of paper, and while solving the problems you refer this sheet. You do this for 1 week. After that you will not be required to see this sheet because you will learn all the values by heart by that time. It's just a matter of practice.